Now this flowchart is basically divided into two parts, subtraction and addition. Again we need two numbers a and b to perform both the operations. If you remember, in the previous video we made a table for signed magnitude numbers, right, where the addition and subtraction operation actually depended on the sign of the two numbers. So in this case, to find whether subtraction will be performed or addition, we need to check if the sign bit of the sign of the two numbers is same or different. For that we are going to perform XOR between the sign bit of the two numbers. AS and BS are the sign bit of the two numbers, and what we are doing is performing XOR. The result of XOR gate is given here. That means if the sign of the two numbers is same, the result of the XOR gate will be 0, otherwise it will be 1. Now if you see the previous video, you can see for the addition operation, when the sign of the two numbers were same, that is the first and the fourth case, the addition was performed. That is for 0 0 or 1 1, where the value of XOR gate will be 0, that is 0, addition is performed. Here the XOR gate results in 0, that is the sign is same. For add, that is the first and the fourth case, and addition will be performed where addition of A and B is performed here, and the result is stored in EA, and the value of E was transferred to AVF, and where AVF was add overflow flip-flop. In the second and the third case, where the sign of the two numbers was different, subtraction was performed. So what we are doing here is, in these two cases where the sign bit is different, XOR gate results in 1 and it will going in the subtraction part. Similarly for the subtraction part, if you remember, when the signs were same, subtraction was performed. So in this case 0 means signs are same and subtraction is being performed, whereas in other case addition is being done. Coming to the subtraction part, what we are doing is we are adding the 2's complement of B to A, and the result is being stored in EA. Okay, now the value of E determines which number is greater. If the value of E is 1, A is greater than or equal to B, otherwise it is smaller than B. Now in the case where A is greater than or equal to B, if it is greater than B, that means if it is not 0, the result is already found and it is already stored in A and AS. But in the other case, it can be equal to B. In that case, the result will be 0, because A minus B, where A is equal to B, it will be 0. Sign bit will be set to 0, that is positive, resulting in a positive 0. In the other case where A is smaller than B, in this case we need to perform little operation, that is here we need to find the 2's complement of A, because B minus A has to be done. So what we are doing is basically finding the 2's complement of A here. Firstly finding the complement and storing in A. Now this A is basically A complement and adding 1 to it and storing it in A. So this is how we find the 2's complement, and the result is again stored in A and AS. So this is the flowchart of addition and subtraction, which shows how actually addition and subtraction of signed magnitude numbers is performed. I hope this video was useful to you. Thank you.